Right then, everyone, settle down. Today, we are going to build a very practical program, a library system, right from the beginning. Let's get started with this explainer.
Here is our plan for today. We'll start by understanding the problem. Then we'll design our class, write the code step by step, and finally, we'll do a recap. It's a simple, clear path to our goal.
So first things first, before we even think about writing a single line of code, we need to be crystal clear on what our program should actually do. This is the most crucial step in any project. Beta.
I want you to think about your school or college library. When you borrow a book, the librarian makes an entry, no? And when you return it, it goes back on the shelf. We're going to build a simple digital version of that very same system.
So, these are our minimum requirements. For our program to be useful at all, it must be able to do these 5 things. You can think of this as our checklist for success.
Excellent. Now that we know what to build, let's figure out how we're going to build it. We'll move to the design phase and start planning the structure of our library class. This is going to be the very heart of our program.
I want you to think like a librarian for just a minute. What are the most essential pieces of information you would need to track to run the library properly? What data must the system remember at all times? These 4 variables, or properties, are basically the memory of our library. We'll have 2 arrays to hold the books themselves and, crucially, 2 counters. Now, these counters are the real key. They tell us exactly how many books are in each array at any given time, which is going to prevent a lot of confusion later on.
So, our first array, available books, well, it's going to hold the titles of all the books that are currently sitting on the shelf, just waiting for students to come and borrow them. Very straightforward.
And our second array, issued books, is just as important. It's our digital register, and it's going to track every single book that has been checked out. For now, we're only tracking the title, but you can already imagine how we could expand this later to include student names also, no?
Okay, with our plan all ready, it is time to lay the foundation. And the very first thing we need is a special method called a constructor. Think of it like the setup crew. It gets our library object ready for business. Now, this piece of code is special because it runs only one time, at the exact moment we create a new library. Its only job is to set up our initial empty state.
So look, the constructor takes one piece of information, the maximum capacity of our library. It then builds the empty bookshelves, which are our arrays, and it sets the counters to 0. And just like that, our library is now officially open, but it's completely empty.
Now for the simple parts. Let's write the code for stocking our shelves with new books and for, seeing all the books we currently have available.
The logic here is very straightforward. First, obviously, we check if there's any space. If there is, we add the new book. And finally, and this is very important, we must always remember to update the counter.
And this is exactly how that logic looks in Java. You see, we use available count as the index for the new book. And since arrays start at index 0, this works perfectly. If available count is 0, the book goes into index 0, and then we increment the count to 1, ready for the next book. Very clever. Okay, everyone, listen up. This next part is the most complex, but it's also the most clever part of our whole program. This is where the real magic happens, so pay attention.
Now, I want you to think about this carefully. If our books are lined up neatly in the array, and someone comes and takes one from the middle, what happens? We're left with an ugly, empty gap in our array, and that is going to cause all sorts of problems for us.
Let's see an example. Imagine our available books array looks just like this, with 3 books neatly arranged at indices 0, 1, and 2. Now, a student comes and wants to issue Sherlock Holmes. If we just set index 1 to null or to empty, our method for showing available books might get confused and stop working properly. Our add book logic could also break. It's just very untidy and is practically guaranteed to lead to bugs down the road.
So here is the solution. We must shift all the books that came after the issued book 1 position to the left. See? Java programming moves from index 2 to index 1, filling that gap perfectly. This keeps our array neat and compact, with no empty spaces in the middle.
So let's see how this all comes together in a complete process. First, we find the book. Second, we add it to the issued books register. Third, we perform that clever array shift to close the gap. And finally, we must update both counters. Available count goes down by 1, and issued count goes up. This keeps all our data perfectly organized.
And just like that, we have built a complete working program right from scratch. Excellent work, everyone. Now, let's quickly recap the main concepts we covered today to make sure they really stick in your minds.
You see, these are fundamental programming concepts. Today, you have learned how to use arrays with counters to keep track of your data. You have mastered the array shifting technique to properly remove elements. You've also seen how a constructor initializes an object, getting it ready for use. And, while we didn't show the code, finding the book would require comparing strings with the .equals method. Remember, Beta, never use double equals for strings. These are skills you will use again and again.
So, I'm leaving you all with this final thought. A good programmer is always thinking about how to improve their code. What's next? How would you add student names? How would you handle due dates and late fees? I want you to think about it. Keep coding, and I will see you in the next class.